Um, 3 there. P2. Ba3P2. And they also ask you to name this guy, SO3, right? Now we know from experience, right? This guy right here is called barium phosphide, right? Okay? Ba, you simply write down barium. All right? And for the P, you simply write down phosphide. And you're done. So let's follow that same pattern with this guy. Barium phosphide. Might call this guy just sulfur oxide, SO3. Sulfur, right? Oxide, and I'm done. The funny thing is, folks, if you said sulfur oxide for this, you would be wrong. If you said barium phosphide for this, you would be correct. Reason being, guys, before you start naming or doing dot structures for things, you have to know what? You have to know whether or not the compound is ionic or covalent. If you have a metal with a non-metal, okay, that's ionic. But if you have non-metals only, that's covalent, and it has its own naming system, okay? So today we're going to look at naming, all right? Binary, all right? Covalent compounds, alrighty? Okay, now once again, how do you recognize covalent compounds? It's made up of non-metals only, alrighty? No problem. Now, a bit of background, we know that ionic compounds, they share electrons, right? They transfer electrons, metals lose, the non-metals gain, they form positive and negative ions, attraction, right? Covalent compounds, they tend to share their electrons in the valence shell, okay? We'll talk more about that later on, okay? No problem, because we haven't done that in my class yet, but they tend to share electrons, right? So make a note of that. Covalent compounds tend to share electrons, all right? Minus. Now, here's the thing, guys. We have to follow some rules before we start jumping to naming them, right? So here are a couple of rules, all right? Number one. The first guy in the name of the covalent compound, once you establish a covalent compound, okay, it stays as is. The only modification that you put in front of it is a prefix, a Greek prefix. Like if you have 2 or higher, then you're going to use a Greek prefix, okay? All right. Point number 2, rule number 2, okay? The second guy in the binary covalent compound, okay, it gets an IDE ending, okay? So, just like in the binary ionic compounds, the second guy gets an ID ending, okay? Oxide, fluoride, chloride, and so on, right? And we also, guys, use Greek prefixes from 1 through 10 to indicate how many of the second guy we have, okay? We'll do some examples in a second. All right. Now, point number 3, right? We're going to modify the prefix name depending on the second guy. Sometimes if the second guy starts with an O or it starts with an A, all right? We're going to modify the name of the prefix. If it's from tetra to deca. Now, once again, if that stuff that I just said is not kind of confusing, I'll show you with an example, all right? So don't worry about it, no problem. Now, before we jump in again, we have to know what? We have to know our Greek prefixes, yes? Okay, so let's go. Now, a lot of these guys you've done already in middle school or kindergarten or whatever, no problem, like hexagon and so on. Well, let's go. So, we have mono, right? That's going to be for 1, okay? We have di. So 1 there, mono 1, di is 2, tri would be 3, okay, tetra is going to be 4, so you guys can see that, and penta is going to be 5, all right, no problem. So those are our prefixes for 1 through 5. 6 is going to be hexa. Alrighty, that's 6. Okay, 7 is going to be hepta, right? 8 is going to be octa, all right? 9 is going to be nona, all right? 9 down, and 10 is going to be decade. All right? No problem. And my point again is, these A's, right? Sometimes they will be dropped depending if the second guy begins with an O or an A. But we'll Now, if you're not sure, use your reference table. You have your atomic numbers on your periodic table. You have table S with all the list of the names of the actual elements. No problem, it's nitrogen. Now, it just so happens, right, since it's N2, you have two nitrogens. So you have to indicate the fact that you got two nitrogens in this covalent compound. Now, how do you know it's covalent? Once again, is you have non-metal and non-metal. So once again, you have non-metals only, then it's covalent, okay? Don't mix and match, don't guess. All right, so you're gonna say what? You're gonna say I'll write it over here, dinitrogen. All right, to indicate the fact you got two nitrogens. And how many oxygens do we have? You have 3 oxygens. Now be careful, you have to modify the second guy, right? ID ending. And we're sort of kind of familiar with the endings from binary ionics, right? So simply say trioxide. And you're done, okay? Dinitrogen, 2 nitrogens, trioxide, 3 oxygens, you're done. Move on to the next guy, CH4. You only have 1 carbon, right? And for the first guy, we don't say mono for the first. If the first guy's only 1, we don't say mono. Just call it as the name as is. So we can simply say carbon, right? Carbon, bam. All right. Now you have 4 hydrogens, right? So prefix of 4 is tetra, and hydrogen will be modified since he's the second guy with the ID ending. So you say tetra hydride. Okay, and you're done. Alrighty. Now the funny thing is, guys, CH4 has a common name of methane, right? And that's used much more than carbon tetrahydride. But since we're doing the formal IUPAC naming for these binary covalent compounds, this is carbon tetrahydride. Okay, no problem. All right, this guy right here, how would you name this? It's B2SI. Now you got 2 B's, right? B's just happen to be boron, so you say diboron. Alrighty. Okay. Now you only have 1 SI, right? You have to modify the name, so it'll be what? 1 is mono, so you say monosilicide. Okay, bam. Done. Alright. Diboron, 2 borons, 1 silicon, done. This guy right here is Cl2O5. Now how would you name that? Okay, you got 2 chlorines, right? So simply say dichlorine, right? So right here. Dichlorine. Okay, alrighty. You got 5 oxygens. Now the thing is, when I talk about the modification, right, with the prefixes, is that since we have oxygen begins with O, right? We're not going to say pentaoxide. We're going to drop the A of the penta, okay? So we're going to say pentoxide. Pentoxide, okay? So notice, instead of saying penta, all right? Penta, we drop that A right there, okay? No problem. So you don't say, erase that. Write it over again. Okay, P-E-N-T-A. This A got dropped because oxygen begins with an O, all right? So pentoxide, you're done. All right. Okay, we have a name here, phosphorus triiodide. Now what we're doing now, we're given the name, we want to get the correct formula, right? So phosphorus is simply P, all right? Bam. No numbers because remember, if it's only 1 guy, we don't have to put mono, and they didn't put mono, so we understood it's only 1 guy. Triiodide, okay? 3 iodines, all right? Iodine, 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 3 of them, and you're done, okay? Notice, right, people, I didn't use any crisscross method. Remember, crisscross we use with ionic, right? In some cases, crisscross works with covalent, but when you're given these names right here, don't use the crisscross method. Bam, just go as is, easy, you're done. All right, dinitrogen pentoxide. Dinitrogen is 2 nitrogens, alrighty, bam. Pentoxide, that's 5 oxygens, right? And 2O5, okay? So, nice and easy. All right, we've got 2 more to do. Dichlorine peptoxide, what would be the answer for that? Dichlorine is simply Cl2, all right? Peptoxide, pep is not making stuff up, okay? So don't mix and match, don't guess, all right? And the last one, okay? Dihydrogen monoxide. Dihydrogen, that's two H's, yes? All right, so you know H2, monoxide, mon is one, okay? Oxygen. Notice, right? We didn't say monooxide. We modified the beginning, right? For since oxygen is O, we modified the ending of the mono to get to drop the O for mono, okay? So normally it would be mono, right? Something, but we drop this O right here, say monoxide or carbon monoxide. Okay, people, dihydrogen monoxide is water. So next time you go to the store, ask for a bottle of dihydrogen monoxide and see the reaction. All right, guys, as always, hard work with sacrifice equals success. This is binary ionic naming and writing. Binary covalent naming and writing. Very simple, but just make sure you know the difference between ionic compounds and covalent compounds. Covalent compounds, non-metals only. Ionic compounds, metals.